What if I told you that we have built machines that stare directly into the blinding face of the sun and survive? Every second the sun releases more energy than every power plant on earth combined. It should be impossible to get close, so let alone study it up close. And yet we do. But how? How do you build telescopes that don't melt, crack or get completely obliterated by the sun's fury? Today we dive into one of the greatest engineering fields in human history, solar telescopes. The machine that let us stare into a star and live to tell a tale. The sun is millions of times brighter than anything your eyes can safely handle. Even a few seconds through an ordinary telescope would instantly blind you. It's one of the most extreme challenges in astronomy. Normal telescopes, useless. Their optics would burn, their sensors would fry, and their mirrors would shatter under the heat. So what did we do? We engineered machines that can stay into hell and keep recording. Now the question is how solar telescopes are different. Solar telescopes don't have eyepieces. You never look through one. They are remotely operated, built with extreme heat rejection systems and surgically precise optics. Now what are those key components that are used in solar telescopes? Now the first one is hydrogen alpha filters. These isolate light at 656.3 nanometers, letting us observe flares and prominences. And the second one is energy rejection filters, ERFs. Block 99.99% of the sun's energy before it hits internal components. And the third one is mirrors, made of low expansion materials like zerodur or fused silica to avoid thermal cracking. And the final fourth one is cooling systems. Some use liquid cooling and airflow circulation to prevent internal temperatures from spiking. And now here's the wild part. Even a micron of misalignment can ruin the image or destroy the entire system. That's kind of tightrope we are walking just to see what's happening 93 million miles away. Most people have never heard of them, but some of the most advanced telescopes on Earth aren't aimed at galaxies, they're locked onto our sun. Now let's meet the titans, and the first one is Daniel K Solar Telescope in Hawaii. It uses a 4-meter mirror. It can resolve features just 30 kilometers wide on the solar surface. Nothing comes close. And the next one is Swedish Solar Telescope, La Palma. It uses adaptive optics to cancel over Earth's atmosphere in real time, like noise cancelling headphones for light. And the third one is NASA's Solar Dynamics Observatory, SDO, and it's a space-based solar telescope. It orbits Earth and captures a new high-resolution images of the sun every 12 seconds. Now the question is why so many and why so advanced? Because what they are watching could change everything. And the question that comes in mind is what solar telescopes are really looking for. They're looking for like sunspots, solar flares, coronal mass ejections. These are more than just pretty visuals. They are signs of magnetic chaos. Solar telescopes helps us predict solar storms, which can tear through Earth's magnetic field and cripple our planet's technology. As in 1989, a solar storm knocked out Quebec power grid in under 90 seconds. Millions sat in the dark. And today, a superstorm could bring down satellites, GPS, internet, planes, even global banking system. And these telescopes, they are not just scientific tools, they are our early warning systems. Now let's talk about the bending physics we have uncovered. Thanks to these instruments, we have witnessed invisible magnetic loops, hundreds of thousands of kilometers long, plasma tornadoes taller than Earth, shock waves that ripple through the solar surface like tsunamis on fire. But there's still one mystery we haven't cracked. Why is the corona, the sun's outer atmosphere, is hotter than its surface? The sun's surface sits at around 5500 degrees, but the corona, it's over 1 million degrees. It defies logic, but we are getting closer to the answer, one telescope image at a time. We are not stopping at telescopes. NASA's Parker Solar Probe is flying straight into the sun's atmosphere, getting closer than any human-made object in history. It's literally flying through the corona where no probe has survived before. But building machines to orbit the sun, that's where things get really terrifying. We are talking plasma radiation and temperatures that melt most known materials. And do you know how we even began to pull that off? Solar telescopes let us stare into fire without being burned. They are not just machines, they are our shields and our eyes on the storm. But watching from afar is one thing. Flying into the sun, that's a whole new level of insane. So in our next video, we are tackling the exact question. What does it take to send a spacecraft near the sun and survive? And the spoiler, it involves heat shields, orbital slingshots and physics that bend your mind. Click the video on the screen to watch the challenges of sending probes near the sun. And if you haven't subscribed, the next time sun flares, your Wi-Fi might just vanish. So subscribe and I'll meet you in the next video.